Hey everybody, this is Larry, this is me going with Q4 of the weekly contest 254, last day where you can still cross. I actually been watching a lot of horror thriller movies lately, so this name is very, this name of this problem is very reminiscent of that. That's what it reminds me of. Anyway, okay, so hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, and especially if you like contest problems and stuff like that, come to Discord. The link is in the description, and we'll talk about problems for as long as you like. There are a lot of other smart people there as well, so they'll help you. But yeah, for this one, I think I actually knew how to do this immediately. The short reason is because I don't know if this is a Leetcode problem or maybe a similar problem, but I did have, yeah, I don't know if this is a Leetcode problem or maybe a similar problem on Code4. So, I mean, there was a similar problem that I remember where it's exactly the same idea, except for you're trying to get from the upper left to the bottom right. And so I used that technique here in that, so the tricky part about this problem is that you're inversing the problem. So what does it mean by, so one thing is that this is also kind of interactive in that there are these cells, so you have to be able to be efficient every time. And here, the rephrasing that I'm going to do for this problem is that instead of going from bottom to, instead of asking if it is possible to go from top to bottom, you ask yourself, is there a blockage from left to right, connecting, right? And what I mean by that is, I'm gonna pull up the drawing program real quick. Hang on. What I mean by that is, oh, did I have it up before okay, no, I didn't. Okay, yeah. So basically, the idea is that, okay, let's say you have a grid. I'm not gonna draw that many things because this is hard. Dot dot dot. Right. The thing is that in this problem, there's a path going from top to bottom, or the opposite question is, when is it impossible to cross, right? It's impossible to cross if you fill in the water, in this case, in a way such that there is a connection from left to right, including diagonals, because you cannot go through diagonals. So in this case, you know, let's say, you know, you fill these out, you fill this one later, and you fill this one, doesn't do anything, you know, this one, you know, now you connect, and now there's no longer a way for you to cross. So that's basically the idea. You can figure out the proofs in general, but, oops, what did I do? But yeah, and it might not be in terms, so that's kind of the idea about this problem, except for the additional trickiness is that, you know, these obstacles are there and you have to do them live, right? And what I mean by that is that you may add them in weird order. For example, you may add them, you know, you may, oh, I could just throw in the color. You may add this one, and then this one. This is still good. This one, this is, oops. Well, I didn't mean to fill out all four, but okay, let's just do this one, you know, and then this one. You know, you keep going. And then now this is still no good. And then this one, now it is no good, right? So you have to be able to do these live where you go, okay, now I can finally connect them here, even though if we go back a little bit, you know, now basically you go, let's say you painted this one, it does nothing except for now you can kind of see that this connects to here. Let's say this one, it does nothing, this one does nothing. And then let's say this one, okay, now they're connected. And then this one, you go, oh, this is connected, right? Yeah. And then eventually, but that's basically the idea. Okay, let me get rid of this. And you know, we've been talking about whether there's a path from left to right, right? And hopefully that should ring something to you. So if you're given a static map where nothing changes, then you know, you could do a depth first search, you could do a breadth first search, you could do whatever, and that'll be fine, right? In this problem, breadth first search and depth first search is going to be too slow because you're going to be adding cells, and it's going to take a while before you add enough cells. If you keep on doing depth first search, it's going to do some quadratic like things, and that's going to be too slow given that we have too many cells, to be honest. So I did leave out one thing that you can do, and it is union find for connected components. And I'm just going to go over now. I usually, to be honest, I don't like going over union find in my videos because it is a college level course that is like really long. You could spend a couple of classes on it. So I'm not going to go over all the details, except to say that if you are having issues of union find and recognizing those problems, work on easier problems first. Look up connected components or connectivity problems, and then after those, after you play around with how to use union find there, come back to this problem. That's what I would say. Put it on the stack and solve item problems first so that you can pop up the stack later if you will. Anyway, so yeah, so this is my general union find. It maybe is a template. I should put it in somewhere because I just essentially I typed this out and it took maybe a minute. Maybe I could have saved a minute. I don't know. I end up solving this in about 10 minutes actually. So maybe I could have saved a minute. And here I have an additional key of the left and the right. These are just constants or placeholders. Maybe I should have used uppercase for constants. But in that case, I also set up the union find parents initialization for left and right. And here we set up the direction and the stuff that we've seen, meaning that seen is the stuff that's on the rows times columns map. So yeah, so I put it on seen. And then now for each cell that becomes water or an obstacle, for every cell that becomes an obstacle, I convert it to zero based first, and then I look at its neighbors, and then to see if if the neighbor is an obstacle, and seen keeps track of that. So it looks at the neighbors. If it is an obstacle, then we union them together. That means that we connect them into one blob, one component, one connected component. And this is if this is in bounds. If this is out of bounds, then I just do two checks. One is that if this is going out of bounds to the left, then we union it to the left. If this is out of bounds to the right, we union it to the right. And then now we check if the left is connected to the right. If the left is connected to the right, then that means that, and this is actually a little bit weird on the off by one, is that we return t because t starts at 0. That means that t is no longer good. That means that, you know, you can think about it as t plus 1 and then minus 1 because we start t at 1 in this case for this problem. And then of course, we mark the obstacle as being done, and that's pretty much it. I couldn't find any assurance that on what the default case is, so I just returned t here. So I don't know if this is even true because I couldn't find any or whether that it is always going to be. Oh, actually no, I take it back. So cells.length is equal to rows times columns, so that means that you're always going to terminate. I actually missed this during the contest, so that means that you're always going to terminate because of, you know, the pigeonhole principle, right? At some point, you're going to connect the left to the right. So this actually never happens then. But yeah. So in terms of complexity, for each cell, we look at 8 directions, and for each of the 8 directions, we do one union and one find. I know that, you know, we can get into details about union find complexity, but let's pretend that this is O of 1-ish for now. So even though my implementation isn't quite that, but yeah, let's say this is O of 1-ish. So in that case, this is going to be linear in the size of the input, which is going to be R times C. So this is, O of R times C time. And in terms of space, we have O of R times C space, because that's what we have for the union find data structure. One cell in the parent. Yeah, you can actually even make that output sensitive, but it's not worth doing it for me here. But you can look at that as a stretch goal at home if you want to make this into output sensitive O of K space and O of K time. I'm where K is the answer T maybe. And the way that you would do it is by not doing another way of initialization, so that you basically don't initialize unless you have to. So because most of the linear cost is in here, right? It's in actually this for loop. So anyway, that's all I have for this one. Hit the like button, hit the subscribe button. Join me on Discord. Let me know what you think. Oh, and you could watch me solve it live in contest next. But I actually knew what I wanted to do immediately. I made a couple of mistakes on implementation that took a while. You can kind of see what I did there. Watch it on 2x or something. But yeah, I'm going to show you the top part and then now the bottom part. Yeah, cool. That's all I have for this one. Let me know what you think, and I will see you later. What a silly mistake. Okay. People already finished. I got a 5-minute penalty on this silliness. Even though, okay. Entire matrix is line. Top to bottom, working only on land cells. Okay. This is easy, I guess. Basically, union find. Let's see. Okay. Let's see. Oh. Mine froze for a second. Okay. And now we have to initialize. 10 was 10 to the 4. Oh, but the sum. Okay. I was worried that I was like that sounds too big, but it's fine. Okay. And then now let's just do left is equal to 0, right is yeah, -1, right? It doesn't really matter what the keys are. And then now for cells. And now for XY in cells. What are we doing in cells? So we do 1, 2. Oh, this is one index. Why would you one index this? Okay, fine. Yeah. Okay. Oh, let's enumerate it for getting the time. What if it's always possible to do it? I don't know if this is good, but okay, that's a default, but what am I doing? So you insert a thing. Okay, fine. I've set stuff. Okay, if y is equal to 0, okay, let's do it the other way. For maybe I said this was easy too quickly. If it's in scene, okay, else y is equal to -1, then we want to union find left. Yeah, okay. If well, this is no good, then this is T because T is whatever. This is way error prone though. I feel like I'm missing something silly. 338. Well, that's not right. Oh. No, this is right, maybe. If one. Well, that's what I get for saying that it's gonna be easy, but oh, it just this never becomes true because this is never true for some reason. We do go here. Okay, so maybe we do connect that, but we don't connect this. Oh wait, whoops, that's right. Forgot a piece. 215. Okay, 213. Oh, so we're gonna do diagonals. Is that right? Trying to think whether that gives me any issues. No, I think we just need to do diagonals. Okay. Let's just write it a different way. I'm writing this a little bit weird as well. Okay, slow down, Larry. Having some trouble today, but okay, I got it. Other than the typing, I got it. Gotta double check this because I feel like I spent way too long and way potential for typo. 213, okay. Do you want to try to give it a submit? Yeah, let's go. Okay, so it's still yeah, thanks for watching. Hit the like button, hit the subscribe button. Join me on Discord, especially if you like these contest poems. We talk about poems all the time of the contest type. But you know, come swing by. Let me know what you think. I'll see you later. To a good weekend, to a good mental health, and I'll see you later. Bye bye.